Hello everyone. In last video segment we are saying that how we are choosing a node that has visited false and that has the minimum distance value. Okay, last time we choose the v3, and when we choose v3, from v3 we checked every other node that we can reach from v3, and we found that if we go from v3 to v6, the distance value we have to update it, because if we go from v3 to v6, the distance value is become 3 plus 5 8, okay, which is less than the current distance. The current distance was 9, so we have to update the distance for v6. Okay, for v6 we have to update it with 8. Okay, and the previous node will be v3. So after we make v3 is known, in that case our table looks like this. Okay, so and also we have to make v3 here, we have to make v3 true. Okay, and we are changing v6, we updated v6 with distance 8, which was 9, and previous node with v3. Okay, so that means if I change the color of the pen, that means now for v6 we are taking the path v1 to v4, v4 to v3, and v3 to v6. Okay, so this is the path we are now taking. All right, all right. Now looks like we have the unvisited node v6 and v7. So between v6 and v7, v7 has the lowest distance, so we are going to choose v7. Okay, so we are going to choose v7. So from v7 where we can go, we can only go to v6. Okay, looks like we can only go to v6. Now if we go to v7 to v6, it will be, the distance will be 3 plus 1 4. Okay, so 3 plus 1 4, and 4 is less than 8. All right, I'm sorry, actually the value of v7 was 5. Okay, the value of v7, it was actually 5. I wrote it wrong. Okay, so it should be 5. Okay, still between v6 and v7 we have to choose v7, because v7 has the lowest distance value 5. Now if I from v7 I can go to v6 only. If I go to v6, the distance become 5 plus 1 6. Okay, and 6 is less than 8, so that means I'm going to update it. Okay, so I'm going to update the distance value for v6 again. When v7 we made v7 known. Okay, we're going to update it to known true. v7 is visited, so the v6 value will again change false. The distance will be 6, and the previous node will be v7. Okay, that means now we are going to take the path, like use a different color, say green. All right, v1 to v7, we go to v1 to v7 like this. First we are going to go to v7, then we are going to go to v6. Okay, it will take the distance 1 4 5 6. Okay, all right, and from v7 can we go to anywhere else? Looks like not. Okay, that means this is the only update we are going to do. Okay, then finally v7 will become true, and v6 is the last node. It is false and it has the value 6, so this is the node we are going to pick. Okay, we are going to pick, so we are going to make it true, and we are going to pick the node v6. We are going to check whether we can go to any other node from v6. Looks like we cannot go to any other node from v6, so this is so that means we are not going to do any, we don't have to do any update. Okay, so our final result result is this result with v6. The distance value v6 is 6. Okay, so let me just write it down here. All right, and I'm also going to draw the path. Okay, so I'm just going to write down the final result. So v1 to distance. Okay, so from v1, v2, v3, v4, v5, v6, v7. So distance v1 to v1 is 0, v1 to v2 2, and path is v1 to v2. Okay, so v1 to v3, the distance is 3, and we are taking the path, and you can find out actually v3 how you can find it. So v3, the previous path is v4, and then go to v4. Okay, then go to v4. The previous path is v1. Okay, so then here the path is v1, v4 to v3. Okay, so that means I am reaching v3 from v4, and how I am reaching v3 how I am reaching v4 from v1, and that is our first source node. Okay, so v1 to v4, okay, then v3. All right, so v4 1, and the node is v1. So v1 to v1, v4. Okay, so v5, the distance is 3, and how I am getting to v5, v4, and v4 to v1. So that means v1 to v4 to v5. Okay, so v6, the distance is 6, and the last distance, previous distance, is v7, and how I got to v7 from v4, how I got to v4 from v1. Okay, that means v1 to v4, v4 to v7, v7 to v6. So v1 to v4, v4 to v7, v7 to v6, and the v7 is 5, v1 to v4 to v7. All right, so that's how the Dijkstra algorithm works. That means we start from the single source node, and then we first use the direct edge and change the distance value. Okay, change the distance value. Then at each stage we pick the node that has not been visited yet, and that has the lowest distance value. Okay, because by picking this path, it has the more probability that from this node we can reach other node with the lowest distance. Okay, so you can see that's how actually the greedy algorithm works. Okay, that's how the greedy algorithm works. We are actually make a decision on every stage. From every stage we are choosing the path. Okay, from every stage we are actually choosing the path what appears to be the best thing at that stage. Okay,